Welcome back, guys. And now let's solve our first questions related to the marginal utility by having a very common and typical Cobb-Douglas utility function, which is the u xy is equal to the x to the power of alpha, y to the power of 1 minus alpha. So now let's find out the marginal utility of x and also the marginal utility of y. The marginal utility of x and the marginal utility of y. Based on the formula, the marginal utility of x is equal to the change in utility per 1 unit of consumption of x, or the partial derivative of utility with respect to x. Then the marginal utility of x in this typical Cobb-Douglas utility function is equal to the partial derivative of this function with respect to x, which is equal to alpha multiplied by x to the power of alpha minus 1 multiplied by y to the power of 1 minus alpha. And we can further simplify it. Alpha multiplied by x divided by y to the power of alpha minus 1. Alpha multiplied by x over y to the power of alpha minus 1, because when we move this one to denominator, so the sign will shift. So this is the marginal utility of x. The marginal utility of x. And now let's solve the marginal utility of y. Then the marginal utility of y is equal to the change in utility per unit of consumption of y, or the partial derivative of utility with respect to y. Then it's equal to, let's take the partial derivative of this function with respect to y now. It's equal to 1 minus alpha multiplied by x to the power of alpha multiplied by y to the power of 1 minus alpha minus 1. Then we will have only minus alpha. And finally, the marginal utility of y, will be equal to 1 minus alpha. You can further simplify it, and we can write down as a x divided by y to the power of alpha. So then this is the marginal utility of y that we have for this typical Cobb-Douglas utility function. So see you in the next video.